you're at home, feel free to pause this and check your answers. This is the first 4. And then here's the next 2. And then we're going to get our notes set up for today's lesson. All right. Okay, so yesterday we were talking about slope. That's one way to describe a graph. We're also going to today talk about your x and y intercepts. So our learning target today is I can identify the slope x-intercept and y-intercept. Given the graph of a linear equation. Before we get too deep into x and y intercepts, which is kind of our new concept for the day, I do want to share 2 special types of graphs with you. I want you to be exposed to them and see what kind of slope that they have. These are our special graphs. Okay, so I'm going to get 2 coordinate planes set up side by side so that we can take a look at these 2 special graphs. Okay, so far we've only looked at graphs that have some kind of steepness to them, okay? They're at a diagonal. Today we're going to look at graphs that are straight up, so vertical graphs and horizontal graphs. So let's take a look. We're gonna look at this vertical graph. And at a later date, we'll look at the equation that makes this type of graph. And then a horizontal graph. But today we're just going to focus on the slope of these graphs, and then we'll go back later and talk about the equation that creates them. Okay, now just like we did when we were finding any slope, we're going to pick 2 points on this graph. So here's a point where it crosses exactly, and here's a point where it crosses exactly. So we're using the same procedure that we did when yesterday when we were finding slope. Let me get it a little bit bigger for you guys so you can see. So the first thing we're going to do is we're going to identify the slope, and then we're going to discuss it a little bit. Now remember, m is the variable that we use for slope. So, and remember that slope is your change in y, which is oftentimes referred to as the rise. And then your change in x, which is referred to as your run, how far left and right. So let's take a look here. Your vertical change, how much is this graph going up? 2 spaces, right? Between your points, your vertical distance is 1, 2. So your change in y is 2. Now, what's your change in x between those 2 points? Yeah, I see it. 0. They're lined up. There is no change in x. Now, here's my question for you. Can you have a fraction with a denominator of 0? No. So that means that when you have a vertical line like this, there is no slope. So if I ask you what the slope of this line is, you're going to write no slope. Yes, ma'am? How I got it? This? Okay. I just picked 2 points on the graph like I would for any line. I did my vertical change, or my change in y, which is 1, 2 spaces. That's how I got 2. And then I did my change in x, which in this case, it's not going to the left or right at all. Those 2 points are completely lined up. So my change in x is 0. Okay? So anytime you have a vertical line, that is no slope. And if you think about it, you can't stand on a vertical wall. Okay? You're just going to slide right down. There's nothing to stop you from just falling straight to the ground. Okay? So this would be considered no slope if your line was vertical. Okay? Now let's look at our horizontal line. Yeah, Maddie.
Does that have something to do with like dependent variable and independent variable? Like if the sub's horizontal or not?
Yes, but we're not going to look at the equations of these until another day. But yeah, it will have an effect that will definitely be impacting whether or not these lines look like that. All right, next one. Again, I'm going to do exactly what I did before. I'm going to pick 2 points on this graph, here and here. So I'm going to do my change in y on the top. In this case, how much is y changing? 0. It's not changing at all. So your change in y is 0. And what's your change in x, given these points that I put on here?
3, 4?
Yep, 3. I know it's kind of hard to see, but I did my points 3. If you did your points closer together, you may have gotten 2, you may have gotten 1, you may have gotten 4. It actually doesn't matter, because what is any fraction that has a numerator of 0?
0.
It's just 0, okay? So the slope here is 0. So all vertical lines have no slope, really nothing to grip onto. You're going to fall right down. And then any horizontal lines has a slope of 0. And if you think about it, if you put a ball on a perfectly horizontal surface, it will not roll one way or the other. It will stay right where it is. Yep. So its position stays right where it is. That's 0. Okay? So those are our special graphs. I wanted to introduce them to you. We will revisit these, especially when we are relating these graphs back to the equations. And now I want to show you x and y intercepts. So I'm going to scoot this up a little bit. So let's start by looking at an example, and we're also going to be revisiting slope a little bit too, because practice makes perfect. So we're just going to keep talking about slope even when we moved on to some other things. Okay, so I'm going to set up my graph here. And I do recognize that you guys are trying to recreate these on your paper, so I will let you know where it crosses to help you out a little bit. So this point right here is crosses the x-axis at 4, and this point right here, it crosses the y-axis at 3. And I'll zoom in a little bit on this too so you can see it. Yeah, Elizabeth.
Can I borrow a ruler?
I'm not supposed to be like letting you borrow things and then taking them back, and I have to sanitize them all the time. So maybe just use like the edge of like a 3x5 card or something. But you should make sure you always have, you should have a ruler with you every day. I think it'll be really helpful for you. I was gonna give you a 3x5 card and I just don't think it happened. Here, I'll just sanitize it when you're done.
Thank you.
So if you have a ruler at home, make sure to bring one. It will be helpful for you. All right, so let's talk about this. First of all, is this slope negative or positive? Show me with your fingers what you think. Negative or positive? So negative or positive? Remember, you're reading the graph from left to right. So as you go from left to right, is it going down or is it going up? Yeah. Okay, good. It should be negative. You should be telling me that this slope is negative. Okay. That's the first piece of information we're going to pull out from that graph. And a lot of kids can tell me, yeah, I can tell if that graph is negative. But then when they actually give me the slope, they forget to put a negative sign there. So don't forget, okay? Now let's go ahead and actually find that slope. So I'm going to make my triangle here. Okay. So I'm running or going over 4 spaces. And then I'm going down 3 spaces. So this is going to be -3. Which means that my slope, m, is equal to -3 over 4, okay? A lot of times this is called the rise over the run. So this is how much you go up or down, and then you're running left or right. Yes?
How would it not be 4 maybe 3?
Because you want your change in y over your change in x. Yeah. And that's actually, that's a great thing to point out. That's a very common mistake that people make is they put the change in x over the change in y. But it's always supposed to be your change in x, this vertical one, over your change in y, which is your horizontal. Okay? Now that we have that information down, let's take a look at the intercepts because this is a pretty straightforward concept, but you do need to know it. Where your line intersects the x-axis and the y-axis, we have a special name for those, and it's called the x-intercept and the y-intercept. So we're going to first look at the x-intercept. Okay, which wherever this line crosses the x-axis, this right here is considered your x-intercept. And in this case, x is equal to 4. So where it crosses the x-axis is your x-intercept, and in this case, it is 4. Yes, ma'am?
If it was higher up on the graph, it would be like 4, 1 or something?
No, because
It would always be 4?
y would always be 0.
Okay.
Because if it's on the x-axis, your y is 0. So you can also describe this as the point 4, 0. And then your y-intercept is where that line crosses the y-axis, which is right here at y is equal to 3. So we can say that your y-intercept is 3. And we can also describe it with this point: when x is 0, y is 3. Okay? Okay, so let's, I'm going to show you one more so you can see what happens when your graph does not cross the axis, and you'll have to figure it out. Sure. Okay, so let's go ahead and graph the line here, and I'll give you some points so that you can make sure that you get it exact. It crosses right here at 0, 3. It also crosses right here at 4, 5. So if you want to use those 2 points to make sure that your line is correct before we start talking about it, that would be great. Okay. So let's take a look here at this one. First of all, is the slope positive or negative? Yeah, positive. Good. You can see that from left to right, it's going up. Mr. Positivity, everything is looking up. What's up, Bram?
So for the first example that I did, if it was like, if like the point was at like 1, 4, what would you put for the x-intercept?
Well, you would need to follow it all the way till it crosses the x-axis, because the point 1, 4 is not on the x-axis. So if the graph does go through that point, that's great, but that is not your x-intercept. You have to make sure you see where it crosses the x-axis, or figure out where it crosses the x-axis. Because you can see on this graph right here, you don't actually get to see it cross the x-axis. So you're going to have to figure out where would it cross. Okay? Does that help? Yeah. Okay. So we've already decided that this graph is positive. So the positive slope. And then are you guys okay with me kind of speeding through the slope here? We already know it's positive. It's going over 4 up 2. It's your rise over your run, or your change in y over x. So that means the slope is 2 over 4, which is 1/2. Okay. And you can actually see the slope when you get it. 1/2, that means you go up 1 over 2, up 1 over 2. The slope is describing that pattern that's happening there as it's going up and over. Now, let's talk about your x-intercept and your y-intercept, because sometimes they're not going to show you where it crosses the axis. So you're going to have to figure that out. And so let's take a look here at this one. We need to get our x-intercept. Yes?
It's hard.
What's hard to see? Oh, here, I'll pull it over a little bit. Okay, so let's go ahead and I'm going to show you what I do to help me figure out where it crosses. I use the pattern that's already there in the graph, because I can see that it goes down, down 2, or down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So I can see that it's going to cross right there, okay? And it might help too to extend that line out a little bit, so you can actually see it cross. Okay. So if for some reason they did not connect that for you, you can connect it on your own. Just make sure that you don't just connect it, because sometimes your line might be slightly off. You actually go through and make sure that, yeah, that is where it would land if I follow the slope pattern. So my x-intercept then is, this is negative 1, 2, 3, 4, 5, 6. So this is negative 6. And then my y-intercept is already very straightforward. It's right here, 1, 2, 3. So that is positive 3. So that was y is equal to 3. X is equal to negative 6. Okay. Let's see. We have like 3 minutes. Do you guys just want to start your practice now, or do you want to do an example with me? Like a practice up here. What? Raise your hand if you just want to start your practice. That's a notice. Raise your hand if you want me to do one more up here. Okay, go ahead and start your practice. I'll turn some music on. Let me know if you need some help, okay?